Hello everyone, and today I'm going to be going over how to solve the Canadian Computing Challenge, or CCC's fifth question from the Junior Contest of 2021, or the second senior question called Modern Art. Now, when you first look at this question, you quickly observe something, that everything starts off initially black, and that every time that he runs this magic brush, it goes from black to gold, or gold to black. Now what this allows us to do is represent this in a binary representation, where black is equal to 0, and gold is equal to 1. Now our final objective is to find how much gold or how much 1 appears in the final pattern. Now when we look at the input constraints, we notice something big. We notice that the size of the grid can be up to 5 million times 5 million, which would make a simulation algorithm completely infeasible, as the amount of strokes is also up to 1 million. Now to solve this problem, we can take a look at the first sample input, which is in the top left corner right here. Now what this tells us is that it is a 3x3 grid, which I can draw out in green, and that there are two queries, one of them that affects the first row, and one of them that affects the first columns. Now right now I'm gonna say that the row queries, which is like something like this, is actually a left to right query, which is easier to understand, because this row query actually affects n amounts of grids, because n is the amount of columns. Now this gets a little bit confusing, so I'm going to call them left to right strokes, and the column strokes I'm going to call them up and down, because the first one is an up and down stroke. So the first stroke that we have here I already have drawn out, and it is a left to right stroke on the first row. And now the second query we have is a up and down stroke on the first column. Now what we notice here is that for every stroke, you actually have +1, +1, +1 on all the grids of along the row, and also +1 here, +1 here, and +1 here. Except this would actually be completely overcounting, because there's an intersection right here. So this would, every time that there's an intersection, this is actually -2, which is not legible. Now this probably will give you a great idea of what we can do, but before we can go ahead into our formula, we also have to note one thing. Every time that there is a stroke in the same row or the same column twice, let's say row 1, the two will cancel out. As you can see, if it starts off at 0, 0, 0, it goes to 1, 1, 1, and if you do another, and if you, like this would go here, and then after that, it would go back to 0, 0, 0. And no matter what the initial state was, after two queries of the same thing, they actually cancel out. Now with this, we can represent this by certain variables. Let's call C as the amount of up and down. So C is equal to the amount of up and down strokes without duplicates. So how would we calculate this? So if there's two of the same strokes, then that becomes 0. And if it's one of the same strokes, then it stays there. For R would be the same definition except for left and right strokes. Now with this, we can go back to our grid that we had right here, and we can actually develop our formula. So we can say total is equal to the amount of up and down strokes, which is also equal, without duplicates, which is also equal to C times the amount of rows, so M. Now why does this work? Let's just go back to our grid quickly. Now every time that there is a C stroke, which is a stroke like this, it affects 1, 2, 3, or M amount of grids. So we can have C times M plus R times N, following the same logic for the other type of strokes. Now what this would actually give us would be an overcounting of this grid. Now as we said before, this would be -2. So every time that there's an intersection, we can just minus off minus 2R times C times 2. Because every time that there's this, you minus it off twice. So that means the amount of intersection is the amount of different lines. Like, you can represent this with lines. So since there's 2 lines, 1 lines, 2 intersections, that's how this part of the formula works. So this is our formula right here. And I'm going to test this on the second sample input just to verify. Now here in the second sample input, we're not even going to draw this out. We're just going to follow our algorithm, and we're going to quickly see that these two cancel out, so we remove them. And these two also cancel out, so we remove them. So the amount of R strokes will be 1, 2, and the amount of C strokes will be 1. Now following our formula, which is total, is equal to the amount of C strokes, which is 1, times M, which is 4, plus amount of R strokes, so 2 times N, which is 5, minus 2 times 1 times 2. Which, if you quickly do the math on this, it equals 10. So now we know that our formula works. Now I'm here in Visual Studio Code, time to code this in C++, but this would be very easy to do in Python too. Now all I've done is copy over the total formula that we have just derived, and I've also done a quick template. Now what this template is that this includes every single header file that there is in C++. So instead of having to do something like include IOStream, include string, this just includes all header files. Now, using namespace std just avoids having to type something like std cout before every single standard library function. So this just saves a lot of typing. And what this is just fast I/O. This doesn't really change anything, it's only good for cin and cout, which is what I'll be using. Now first, I'd also like to make a note that 5 million times 5 million, if the most amount of ones would be 5 million times 5 million, and that would be above the integer limit. So I'm going to try to use long longs everywhere during this program, just so that we avoid overflow. So first we can do long m and n, which is the amount of rows and columns respectively, see in that. And then also use k, which is the amount of strokes. Now this doesn't really matter because all we're doing is iterating through k, so using an integer would be fine. Now we need a way to represent the amount of strokes that there are of each type, and also keep track of duplicates and be able to see if there is a duplicate very quickly. Now the best data type to do this that is built into C++, Python, and almost every major language is a set. Now we don't need the ordering that there is in a regular set, so we can use an unordered set in C++ of integers, and then we'll convert to long later on. Now the first one will be of left-right strokes, which this is actually also row strokes, but I think it's easier to understand with using left-right. And then there's the column strokes, which is up-down. Now we're ready to get into our main loop, which is just simply for, and this is just a very simple definition of a for loop, just to iterate through all the different strokes. Now for each one of these strokes, there is 2 inputs. There is a char character that determines what type of stroke it is, and an integer x, which is what row or column that respectively it is. And we're going to get the input for this. And now there will be 2 cases for this. The first case is if c is equal to a row stroke, which is also a up-down stroke. I mean a left-right stroke. And there's else, which is c equal to a column stroke, which is actually just a up-down stroke. Now the code inside here, both of these are going to be very similar. Now for the first one, we want to check to see if that stroke already exists first. So we're going to see if lr.find and the current x equals to lr.end, which means that it is not found, then we can add it in. So lr.inplace x. Now if it is already found, then we need to remove it from the set. So lr.remove erase x. Now this is basically the exact same code for the other one, just that we change LR to UD. So if updown dot find x equals to updown dot end, then we replace it or insert it into the unordered set. And otherwise, if it already is in there, we erase it. Now that we're done with our main loop, we should compute the total. So long total equals 0 to start off with. Now I'm going to copy down our handy formula here, because we can just copy this exactly. So we can do total plus equal to, and I'm going to put in parentheses long to force the type to be long, so that we do not run into overflow errors. So the amount of rows, so the first one is m, so m times the amount of column or up-down stroke, so up-down dot size. And then now we're going to do that total plus equals long n times left-right dot size. And finally, we're going to minus off the intersections. So total minus equal long 2 times up-down, so the amount of up-down strokes times the amount of left-right strokes. And now we're ready to output our answer. And just like this, we have solved this problem completely. Now I made a small mistake in the code, and I'm not sure if you caught it earlier, but I did a comma instead of a inserting operator for the cin, so that the test cases would actually fail due to undefined behavior. Now, making that small little change, we can see that both test cases are passed, and now this code is going to pass all the test cases inside the CCC grader. Thanks for watching my tutorial on how to solve the S2 or Junior 5 problem of the 2021 CCC contest. And please subscribe to my channel if you want to see more solutions that I'll be posting in the near future. Thank you and have a good rest of your day.